Hello, hello, hello. Today we're going to talk a little bit about something called pedigrees. And basically a pedigree is a fancy scientific way of organizing family history. And so some of us have heard before of the word family tree. And so family tree is a way that normal people might kind of classify their family throughout generations. But scientists will use a special type of family tree called the pedigree. You may have heard pedigrees before, like maybe you've heard of the dog food pedigree before. And the reason why you hear of the word pedigree often associated with dogs is because people want to have dogs that are purebreds, which means dogs that are all one type of dog. So here is Mr. Willie's certified pedigree for his dog Cooper, right? And so he wanted to make sure that his dog Cooper was a purebred yellow lab, that there was nothing else mixed with his dog Cooper. And so what he has here is a family tree of his dog Cooper. So it starts with Cooper right here and shows Cooper's parents, and then his parents' parents, and then their parents' parents. So you can see that Cooper comes from a history of a family of pure yellow labs. So he's a purebred yellow lab. You also hear of pedigrees a lot of times with horses. So people who like to race horses want to make sure that they have a really fast horse. And so to make sure they have a fast horse, they want to get a horse who has a family history of being really fast, right? And so they'll find their family history pedigrees for their horse. We're going to talk about pedigrees today that have to do with humans and human family history. So before we talk about what a pedigree looks like, we need to talk about the symbols used in a pedigree, which are these things over here. So the first two symbols you need to know are a square and a circle. A square in a pedigree is always going to mean a male. And a circle in a pedigree is always going to mean female. Now usually we'd make a pedigree to look at a family history of one certain trait. So if there are individuals in that family history that don't have a trait, their boxes aren't going to be filled in. But if those individuals do have that certain trait, the square or circle is going to be filled in. So a filled in circle or square means that they do have the trait. Now, remember that we talked about how an individual can be heterozygous, which means they have dominant genes and they have recessive genes. And remember that dominant genes are large and in charge. They're the ones that are overpowering those recessive genes. So let's say an individual has recessive genes for albinism. Albinism is recessive, right? And so they have the genes for albinism, but they don't look albino. They do have skin pigment, they have color. And the reason why is because they also have the dominant genes that overpower that albinism. And so the person will have skin color, they'll have pigment in their skin and hair and eyes that overpowers the albinism. But they still carry the gene for albinism. And so we might be able to see albinism in their children. So because of that, a heterozygous individual is sometimes called a carrier. And we'll identify those on a pedigree by coloring them half in. So it could be a circle or a square, and half colored in, those will be carriers. We will see sometimes that a circle and a square will be connected to one another. When a circle or square is connected to one another, that means that they have had children. It can also mean just that they're together. It doesn't necessarily mean that they're married, because we very well know that people don't technically have to be married to have children. If the people are no longer together, you can just determine that by crossing out that line, so they're no longer together. Now, this symbol up here, where we have a boy and a girl, but their lines go straight up vertically and there's a horizontal line connecting them, that would mean siblings. When a parent has children, we'll have two lines between the parents and a line coming down showing that they have children. That line will connect to this horizontal line of siblings. We'll also see in pedigrees that there's going to be different generations, and those different generations are going to have different lines, and we'll see what a pedigree looks like in a second. We're going to identify those different generations with Roman numerals, and so these mean generations. Whenever there's an individual, either a box or a circle, and it has a cross through it, or kind of an X slash mark, that means that that person is passed, and so they're dead. When we have parents that have offspring, and those offspring are both connected at the same line, and so instead of an arrow going straight down and then branching off, they branch off together from the original paternal line. That is called paternal or fraternal twins. And when they come off together and they have a line connecting between the two, that would be identical twins. Alright, so now we know all the basic symbols to a family tree or a pedigree, and so now I'm going to show you what my pedigree for my family looks like. I'm going to do it in this space over here. So we're going to start with me. I'm a girl. So here's my circle for girl. And I have one sister, so I'm going to draw a sibling line just like this. My sister is with a guy, and they have a child together, my niece Cora. Alright, so here's my one sibling. Now we're going to have my parents up here. I'm going to draw them far apart. Here's my mom. Here's my dad. Now my mom and my dad are divorced. They aren't together anymore, so I'm going to draw an X through them. My mom is the youngest of 4 kids. My dad is the youngest of 4 kids. They're a girl, a boy, and a girl. So here's going to be my mom's parents, my grandma Viv, my grandpa Henry. My grandpa Henry is passed. Here's going to be my dad's parents. Here's my grandma Carol, I was named after her. And here is my grandpa G. Both of these have passed. I know that my grandpa's parents and my grandma's parents, interestingly enough, were both named Morris and Marjorie, which is really cool and unique. So that's them. These, of course, are past. I could keep going and going and going to see the generations throughout history, but I'm going to skip that part for time's sake. This is going to be my first generation listed on my pedigree, so I'm going to label that with the Roman numeral 1. Their children, my grandparents, will be generation 2. Then my parents and my aunts will be generation 3. Me and my sister will be generation 4. And my niece will be generation 5. Now remember that we said a pedigree is used to determine a trait throughout family history, right? And so when we have the trait, we're going to fill that box in. And so what I'm going to do right now is I'm going to fill in my pedigree for having brown eyes. And we'll show how you can use Punnett squares to help fill in a pedigree. Alright, my niece Cora has brown eyes. My sister has brown eyes. I have brown eyes. My dad doesn't have brown eyes, but my mom has brown eyes. Now I'm not sure about my aunts, so I'm going to leave them blank. I know that my grandma doesn't have brown eyes, but my grandpa did. Let's say I want to figure out what would happen if Prince Charming that I meet, this really cool handsome man, of course. We want to find out if with him, I'm going to have a child with brown eyes, because let's say I really want a child with brown eyes, if he has a recessive trait and a dominant trait together. So we want to figure out basically if I'm heterozygous or homozygous recessive for brown eyes, or homozygous dominant for brown eyes. Okay, so let's look at my grandparents right here. We know that by making a Punnett square, we know my grandpa will go on top. And we know that he has brown eyes. So we're going to put a capital B. And we don't know if he has brown eyes recessive or brown eyes, we don't know if he's heterozygous or homozygous dominant for having brown eyes. We know though that my grandma does not have brown eyes, so we're going to put 2 little b's here for her. Now my mom has brown eyes, and so if we fill this in so far with what we have, we know that this could be one of her with a capital B because she has brown eyes, and she also could have brown eyes if we put a capital B here. But she could also have brown eyes if we put a lowercase b there. So we don't really know what grandpa was, but we do know that grandma was lowercase b, lowercase b. We know grandpa is big case B something, but we don't know what. We can assume though that my mom most definitely is big case B, lowercase b. Because my dad doesn't have brown eyes, we know that he's going to be lowercase b, lowercase b. So now if we make a Punnett square for my parents, we can see that dad at the top is going to have lowercase b, lowercase b, and we know that mom is going to be capital B, lowercase b. So if I fill this in, we're going to see that me and my sister could either be capital B, lowercase b, or lowercase b, lowercase b. If we were lowercase b, lowercase b, it means we'd have the recessive trait, which is green eyes. But we don't. We know that both my sister and I have brown eyes, which means we have to be capital B, lowercase b. So if I want to figure out if my child is going to have a filled-in square or not, if it's going to have dominant brown eyes or recessive green or blue eyes, what I can do is I can create a Punnett square for me and Prince Charming. I'm going to do that right up here. We're going to see that me, Mom, I am going to be big B, little b. And if I found Prince Charming was also big B, little b, that our kids would have 1, 2, 3 out of 4 boxes having brown eyes, the dominant trait, which is 75% chance that my kids would have brown eyes if I also found a man who is heterozygous for having brown eyes. So you can see that by using a mixture of pedigrees and Punnett squares that we can figure out what future generations will have in regards to traits. It is a little bit tricky, but I know you guys can do it. It just takes some playing around and using Punnett squares. Some people eventually will be able to do that in their head and determine what parents and offspring will have. So I hope that helps. As always, if you have any questions, feel free to let me know. Thanks, guys.